Matrix way to solve linear sets of equations. Let's write down a linear set of equations. This is equation 1. This is equation 2. First thing we need to do to put into matrix, we need to convert it, to solve it with matrices, is to convert it into matrix form. Now this might be new if you haven't seen this before, but it just eliminates, we have always x's, we always have y's. These are two equations, two unknowns. We're looking for x and y. Even if there was no y, we'd put 0 there, or we wouldn't write it. But we always have x's and y. So we're going to make this matrices have a constant x and y variable. So there's always x's and y's, and it always equals something else. Okay, that's why it's important to put in this form. What you have here is you have 2, -1. Okay, 2 times x plus -1 times y equals 1. So there's your first equation. There's your first equation. That's your first row. Let's call it row 1. Okay? Your second equation is 3 times x plus 2 times y equals 12. Okay? So this is how you build a matrix. This row multiplies by this column equals that number. That's the first row, or the first equation. This row multiplied by the same column equals this number. That is going to be your second row, or second equation. And if you had a 3 by 3 matrix, you would have 3 unknowns. It would be x, y, and z. But it would still be put up in the same way. These matrix right here is the A matrix. It is an n by n matrix. Here is a 2 by 2. This one's going to be a column matrix of 1 by n, 1 by 2. And this is also going to be a column matrix of 1 by 2. When solving matrices, what we want to do is we want to convert this matrix into an identity matrix, okay, which looks like 1, 0, 0, 1. 1's on the diagonal, 0's everywhere else, multiplied still by x and y, that doesn't change, equals some numbers, 2 numbers. Okay, we have some numbers. We don't know what they are yet. Because if we have that, when we convert it back into equation form, we will have, let's do what we do. We multiply this row by this column, so it would be 1 times x plus 0 equals some number. And this column would, or this row would be 0 times x plus 1 times y equals some other number. It would give us the solution. It's the identity matrix. Identity matrix. I. Okay? So how do we do that? First things first, to solving this by hand, we are going to change this into row echelon form. Okay, so we're going to change this into row echelon form. We're going to get rid of as much stuff as possible. We're just going to put a 2, -1, and a 1 here. A 3, a 2, and a 12. This is a method of solving this by hand. And what we're going to do is we're going to do a whole bunch of elimination steps. So the first things first I want to do is I want to make this value a 1. So I'm going to take, we have to do this by hand, we're going to do it multiple times here. So I'm going to take row 1 and I'm going to divide it by 2. Okay? So it's like taking this equation and dividing everything by 2. What would you get? You would get 1, -1 over 2, and 1 over 2. That's what you'd get here, right? It would be 1 y over 2 and 1 over 2. But now it's just so much simpler. It's just in numbers. You don't have to write down the equation, write down any equal signs. We know what we're talking about. It's just the numbers. Now here's the tricky part. Now this is going to be a large elimination step, okay? We want to make this value a 0. That's what we want to do next, is we want to make this value a 0. So what we're going to take is we're going to take row 2, this row, minus 3 times row 1 new. I put a little asterisk here to indicate that I'm talking about this row 1 and not the previous row 1. Okay, this is the new row 1. So if I take row 2 minus 3 times row 1, then I would have, 3 times row 1. So I'd have 3 minus 3 times 1 would be 0. That's what I want. Okay? A common mistake here is just to subtract 3. Right? Some people think that it's okay just to subtract 3. Row 2 minus 3. That doesn't make any sense. If you look back to equations, I can't just subtract 3 from each one of these numbers. That doesn't make any sense. It's not mathematically correct. All I can do is multiply or divide, and I can subtract and add, or I subtract and add other equations. And that's what I'm doing here. I'm multiplying or dividing and adding or subtracting other equations or other rows. That's the only operations you're allowed to do in matrix form. Okay, so let's continue on here. So row 2, now this is going to be a little complicated, so I'm going to write down an equation here for this number right here. The equation will be, it's going to be 2 minus 3 times row 1 new, which was negative 1/2. Okay, so what does that value equal? That is going to be 2 minus 2 plus 3 divided by 2. It's going to be 3.5. Okay, so 3.5. So that's going to go right here, 3.5. The next value here would be row 2, so it's going to be 12 minus 3 times row 1 new, which is 1/2 here. So it's going to be 12 minus 3 times 0.5, and it's going to be 10.5. So 10.5. Okay, let's continue on. We got 1 and 0 here. Let's continue on here. So now we want to, what do I want to do here? I'm going to make this guy a 1. Well, that seems kind of easy. I'm just going to take row 2 divided by 3.5. Okay, so 0 divided by 3.5 is 0. 3.5 divided by 3.5 is 1. And 10.5 divided by 3.5, 10.5 divided by 3.5 is 3. Okay. Next one is I want to make this one a 0, or this value a 0. So what I'm going to do here is a more complicated step. I'm going to take row 1 minus, or let's so no, I'm going to keep it. It's always minus. So minus negative 1/2 times row 2 new. Okay, so row 1 minus negative 1/2 times 1 times negative 1/2 times row 2 new. So times 1. It would give me that will make that a value of 0, because it will be 1/2 minus 1/2 negative 1/2 times 1. So it'll be negative 1/2 minus negative 1/2 equals 0. Whew. I keep it negative there because this is where the computer runs it. Why are we doing this? Why are we doing this? You can see that this is the same operation over and over again. All I do is make this a 1, and I subtract everything else. And I do it again. I keep on doing it over and over again. So this is exactly what a computer does. That's why I kept it here. I could have done plus the 1/2, but I just wanted to keep it what is actually written in code. Because this is how a computer solves a system of linear equations. So let's continue on with this. So we're going to have row 1 here. This is row 1. I know it doesn't look like a 1. It's a 1 here. Row 1 minus negative 1/2 times 0. Okay, that's 1. Okay, this is going to be negative 1/2 minus negative 1/2 times 1. That's going to be a 0. That's what we wanted. And now here we're going to have, let's just write it down. So it's going to be 1/2 minus negative 1/2 times row 2 new. So it's going to be 3. And that value is going to be 0.5 minus negative 0.5 times 3, which is 2. Okay, 2. And we have now done our identity matrix. See, we got the 1s in the diagonal and 0s everywhere else. Okay, put it back into matrix form, put our values in there, 2 and 3, and when we put it back into equation form, there's the answer. X equals 2 and Y equals 3.